Hey guys, it's Mr. Post, and on this video we'll be checking out a Newton's second law problem, trying to find the net force of an object, and also trying to solve for the acceleration once we found the net force. The example reads as this: a man is applying a 38 Newton force to a 3 kilogram object at an angle of 29 degrees. If the coefficient of friction is 0.50, what is the net force and the acceleration? So let's start, guys, by looking at what's going on here. Let's read the problem over again. The man is having a force applied, and the force applied is a plus, or a rightward 38 Newton force. He's applying that force to a 3 kilogram object, and the force is being applied at 29 degrees. That's going to be 29 degrees to the horizontal. The coefficient of friction, so there's definitely some friction involved here. The coefficient of friction is 0.5, and the question is really saying what is the net force and the acceleration. So let's do a free body diagram to kick this problem off. I'm going to draw it right over here. We have a surface, and the surface has a coefficient of friction of 0.5, so let's label that there. The man is applying a force. Here's my force applied. The force applied is 38 newtons. So that's my force applied, and that's going to equal 38 newtons. And I'm actually just going to label it right there. That's 38 newtons. And it's going to be applied at this angle right here, and the angle right here is going to be 29 degrees. I also have some gravity definitely taken into account here, Fg, and because we're going to have a surface, the surface is going to exert a normal force on the object, and we also know that there is going to be a force of friction going on here. Ultimately, we want to find out what is the net force and the acceleration. Now this is a horizontally moving object because it's moving across this floor here, so I know that I'm looking for a net force, if anything, in the x direction. Alright, so that's kind of like where I'm looking at. I know in the y direction it's going to cancel out to be 0, so we're going to key in on, zone in on a net force in the x direction. The first thing I would do if I'm going to solve this problem is break out this triangle here. Alright, the net force is applied at an angle. It's applied at 29 degrees. Unfortunately, we have to break that up because we need to find out what is the x component of that force and also what is the y component of that force too. So I'm going to draw the triangle a little bigger. Let's just draw it right over here. This is my net force. This is supposed to be 29 degrees, even though I probably didn't draw it too good there. That's 29 degrees. We have the net force, not the net force, I'm sorry. We have the force applied at 38 newtons, and I guess we're going to have to solve for first either one of these. So let's take our pick, whichever you want to solve for. I'm just going to start off by saying cosine of theta is going to be equal to x over top of 38 newtons. And let's substitute here. Cosine of 29 degrees is going to be equal to x over 38 newtons. And now we're going to algebraically solve for x to find out what is the force applied in the x direction. And so we can see here it's going to be 38 newtons times the cosine of 29 degrees. And we're going to pause, guys, to find out what that value is. And that's going to be equal to 33 point, we'll call it 33.2 newtons. So this value here is 33.2 newtons. Let's solve for the y component over here. This component of our force applied of our triangle. So we're going to do sine of theta is going to be equal to y divided by the resultant. The resultant is 38 newtons. Let's distribute this around here. We're going to have sine of 29 degrees is going to be equal to y divided by 38 newtons. And let's solve for it algebraically. We're going to solve for the y variable here, so we need to isolate it. And so we're going to have 38 newtons multiplied by the sine of 29 degrees is going to be equal to my y value. So let's solve for y here, guys. Y is going to be equal to, and what we find out is that the force in the y direction, force applied y, is going to be equal to 18.42. I'm just going to call it 18.4 newtons. So what we have here is that the force that was applied at 38 newtons at a 29 degree angle to the horizontal. 38 newtons means some of the force is distributed horizontally and some is vertically, and we use their sine and cosine to find out that it's 33 newtons going rightward and 18.4 newtons going upward. Alright guys, so we did part 1. Part 1 was to blow up that triangle. The triangle is blown up. Now we can continue on with the problem here. Now the net force is going to be equal to all of the sum of the forces, and let's just start off with the y direction. So in the y direction, we're going to have the force gravity, we're going to have the force normal, and we're also going to have the force applied in the y direction. And if we start off by labeling them, we have to first solve for Fg. Now Fg is going to be equal to the mass times the acceleration due to gravity. The mass of the object was, let's go back up here, 3 kilograms. So we're going to have a 3 kilogram object multiplied by negative 9.8 meters per second squared to give me an Fg of 29.4 newtons, and that would be negative. So Fg is 29.4 newtons. That's negative. And let's label that down here. We have a negative 29.4 newtons plus the normal force, which we don't know yet, plus force applied in the y direction, which we said was 18.4. And that's going to equal to 0 because the object is not accelerating up or down, it's moving horizontally. So the net force in the y direction is going to be 0 newtons. And we're just going to do a little addition and subtraction here and solve for the normal force. The normal force is going to be equal to negative 29.4 plus 18 plus another positive number. And what we're going to find out in this case, guys, is that the normal force is going to be equal to 11 newtons. So I'm going to go up here, and first let's just square it off. The normal force is going to be equal to 11 newtons. Alright, we're making a lot of headway here, and this thing is starting to really get crowded. So let's find a little bit more room over here. The next place we're going to go is the force of friction. The force of friction is going to be equal to mu times the normal force. And I'm going to continue to work this problem out on this side here. The force of friction is mu times the normal force. Mu, or the coefficient of friction, is 0.5. So we're going to have 0.5 times the normal force. The normal force is 11 newtons. And so 0.5 times 11 newtons will give me a force of friction that is equal to 5.5 newtons. Now this is going to be a leftward force, so we're going to identify it as a negative 5.5 newtons. So here we have the force of friction equal to negative 5.5 newtons. Now we've calculated every single force here. We found gravity is equal to 29.4. We found the normal force is equal to 11 newtons. Force of friction is negative 5.5. The last thing we need to do is solve for the net force and also the acceleration. Now I know this is getting a little crowded here, so why don't we start off by erasing some of the stuff that maybe we don't need, and I'm going to start off by erasing the sine and cosine. So the F net, or the net force in the horizontal or x direction, is going to be the sum of all forces in the x direction. And right now, in the x direction, we have the force of friction, and we also have the force applied in the x direction. And that was this over here. And if we start adding them up, the force of friction is going to be negative 5.5 newtons. And the force applied in the x direction is 33.2 newtons. And when we solve for this, we find out that the net force is going to be equal to 27.2 newtons. So now we've solved for the net force. The last thing we have to do in this problem is solve for the acceleration. Anytime we have a value for the net force other than 0, there's going to be an acceleration. The net force is a positive value, it's rightward. That also indicates my acceleration will be positive or rightward acceleration too. And we're going to use the formula that the net force is equal to the mass of the object multiplied by the acceleration. Let's do a little substitution. The 27.2 can be substituted in here. 27.2 newtons is going to be equal to the mass. The mass was originally 3 kilograms multiplied by the acceleration. And 27.2 now, we have to isolate it for A, divided by 3. And we're going to see acceleration is going to be roughly equal to 9.1 meters per second squared. Alright guys, there we have it. We've solved for the acceleration, we've solved for the net force. We've done all the work involved. It's a big problem. If you want some extra help in it, I'd say try it again. Try it on your own without the video and see how you do. Come watch the video at the end to make sure you did the problem right. Alright guys, thanks a lot for tuning in. Have a good night. Peace.